Welcome to another exciting episode of the NIDS View, a weekly show of the National Institute for Deterrence Studies, where we are advancing peace, promoting stability, and helping you to think deterrence. Each week, we discuss and analyze a recent topic and provide insight into how it affects our national deterrence. We hope you enjoy this show.
Welcome back to another great episode of the NIDS View. Of course, I'm Adam Lowther along with Jim Petrosky. Now, our co-conspirator, Curtis McGiffin, is on leave this week, but he'll be back next week. So we'll of course miss him, but I know he will be sitting in a nice warm place and thinking about this very topic, and probably listen to this episode when it comes out and be like, I would have said something really smart. And so, we'll miss him. Jim?
Yeah, Curtis is already in a warm place. He's down in Tennessee. And actually, if you're in the United States at this point, it's warm for this time of year anyway. So all is well with the temperatures. But I agree. I miss having Curtis on here, but we'll get by without him.
So we had a bit of a, can I say it's a kerfuffle when Congressman Turner announced a few days ago that there is a major problem that has come to light to the Intelligence Committee, and he was advocating for President Biden to declassify the information. And of course, in the days that followed, the last few days, it's really only been 2 or 3 days, it's come to light that there appears to be, the Russians appear to have or are building a nuclear-powered anti-satellite weapon. We don't exactly know what it is. I mean, I've read a handful of the articles talking about it, and it would essentially be a nuclear anti-satellite weapon. And of course, this has, severe implications for the United States, right? Position, navigation, and timing is essentially one of the most important things that we rely on for everything from the transmission of power to ATMs to, a whole host of just normal daily things that if it were disrupted, that would be a big deal. If we had a nuclear detonation in space, we could potentially lose our communications and, intelligence satellites. So this is like a really big deal. But the administration came out and said that they don't think that it's an operational capability. John Kirby said they think that they're building it, but it's not operational at the time. And then, of course, fortunately, President Putin came out and said that this was a malicious fabrication, end quote, by the Biden administration to pressure Congress to pass the $97 billion foreign aid bill. So, I mean, really, we probably shouldn't have talked about it, on a NIDS View episode, because President Putin said there's nothing to it. And, the Russians always keep their word on treaties. They don't ever violate them, because it would be a violation of the Outer Space Treaty. So we shouldn't worry. President Putin said so. Now, Jim, let me ask you. So we don't know a lot, but let's sort of hypothesize. And you being the scientist, you're good at, generating hypotheses and then doing experiments and things of that nature. So what would, if this were to be real, if let's say the Russians have some sort of nuclear detonation device in space that was designed to essentially take out American assets, really any assets, whatever it comes, whatever would be in the, in the path of this device and the propagation of those, the harmful radiation. So what would happen? How would that look? What would be, what could we expect? Give us some details on the science of what we might see.
Yeah. Oh, well, thanks, Adam. And first of all, just to be clear for everyone, I am in Congressman Turner's district, so I obviously know a lot about this because I'm in the right area. But to put in a plug for our NIDS knowledge, for those that haven't been listening, we opened up a new venue a little over a month ago in real space strategy, and our space strategy expertise is Chris Stone, who does that on an every other week basis, and he's addressed this topic a little bit before. But I'll give you a different I'll give you a slightly different view, Adam, and I appreciate your introduction. You said I do hypotheses. I call it, brevity science, BS. So I can do just about anything in that realm. But in all seriousness, space operations is not my background, but nuclear weapons and nuclear weapon effects are, and certainly space is an important aspect because, first of all, even without nuclear weapons, anything traveling in space has to be designed to be able to weather through environmental conditions of radiation from the cosmos and from the sun. And so a lot of what we have in space, of course, is radiation hardened. They also, of course, with the solar, with the sun on one side and space on the other side, they have to be able to handle, high thermal differences in satellite communications equipment. And so our systems in space are somewhat hardened against the harmful radiation of space. My apologies. But a nuclear weapon in space, and you, Adam, you said nuclear powered. I'm not sure we're building, and we've done this with deep space aircraft already, where we have radiation based propulsion systems in space. But I read on this this argument here is that they're breaking the space treaty. At least that's that's what's being pushed in this article, is that they're putting a nuclear weapon in space. Let me first start out just with the technical background. So when you have a nuclear weapon in space, there's really two major things you've got to look at. Actually, probably more like three. You have the prompt radiation effects. So when a nuclear bomb goes off, it puts out a lot of radiation. X-ray is probably the most important, and it's a direct line of sight. There's nothing in space to stop it. So there are very, very high fluxes of X-ray, which can ionize the surface of other satellites, and also can place a huge amount of thermal energy onto a satellite, causing melting or destruction. But what people don't know about very often is those X-rays come as a short pulse and give an incredible, this is sort of interesting, called X-ray impulse, give an incredible impulse, or basically a shove to the satellite. And they're not mechanically designed to take a shove in space, because in space, once in orbit, an aircraft or a spacecraft is pretty much just floating along in space. There's no wind. There's nothing, not a lot of drag aside from, there's some drag, cosmic drag that comes, and gravitational drag, but you don't have, tornadoes and wind systems and such in space. So they're not designed for that. So that's one area that, our current systems are not designed to, necessarily, be able to take on. And we're talking impacts that are much higher than just a straight impact of an aircraft or something like that. So there's direct prompt radiation effects that occur. And that's the first thing that the satellites must be able to survive with a nuclear weapon in space. And I want to get this third point I want to make quickly here. The second piece is there's residual radiation, because when the nuclear bomb goes off, it puts out, the fuel itself becomes radioactive. The surrounding satellite components become radioactive from the excess neutrons. They basically activate it. If you don't know anything about that, listen to my NIDS knowledge podcast on fallout, and I talk about that at some length. So if that doesn't sound right to you, listen to that discussion, because it's about neutrons interacting with materials and activating them. So now you have this residual stuff. So first of all, anything that doesn't kill you at first because you're within line of sight of the satellite, you're on the other side of Earth or whatever, eventually you're going to rotate around the other side of Earth, or the magnetic field is going to move that debris to the other side of Earth and impact with you. And it's radioactive. and that radiation's going to damage electronics and can damage surfaces and can cause electronics and other systems to fail. And we knew this way back. I mean, back when we established a treaty for space detonations, because we knew what was the name of the treaty, Adam? We had
Outer Space Treaty. What are you thinking of?
Yeah, that's what I'm thinking of. But I didn't think it was called the Outer Space. There's actually a name for it. It'll come to mind as I'm thinking about it. Exoatmospheric Test Ban Treaty.
Okay,
so,
I got you. Right.
Yeah.
Starfish Prime.
Yep, there you go. So, so we did not want to have that happen. We wanted space to be able to be used, because this debris can be radioactive for long, long periods of times and affect many things. And that's the piece that bothers me about any of this is if someone were to put a nuclear weapon in space and detonate it, you basically are taking space off the map in terms of a warfighting domain, because it is so unpredictable. Go ahead, Adam.
Well, let me ask you, though, as I was trying to think about, like, how would the radiation propagate? Like, would it propagate, in a belt? Would it propagate, in all directions? How would it propagate in space to therefore, and how thick of that would that layer be? Those are some of the things I was trying to think about.
So you get back to fundamental physics. Hopefully our readers are more than interested in Newton's laws, but seriously, again, this is why I see a nuclear weapon in space as being somewhat concerning from a standpoint of not knowing what the real result is going to be. Because what happens when an explosion occurs is you push debris in multiple directions, and so an object in motion will remain in motion unless a force acts on it. And so what ends up happening is the initial explosion, I'm moving my hands around for those potentially watching the video. But what happens is that debris moves out. There's nothing really to stop it from moving, higher to a higher location or a lower location from the actual detonation. So what it causes it to spread out. Now it's also moved by the magnetic field of the Earth itself. And so the positives go one way and the negatives go the other way, and they actually pick up a cyclic motion due to some other external magnetic field forces. And so what you get is this slowly growing region where you go to higher altitudes, you go to lower altitudes, and you pretty much spread it out either through that initial kinetic energy or through what's called diffusion. Things go from high to low concentrations. And so it diffuses out very slowly over time. And when we had previous detonations in space, they affected our atmosphere for 5 or 6 years. We could still see the residual effects of that radiation in space before it either diffused enough that it was low enough, decayed enough so it was low enough that it didn't cause any problems, or literally came out of orbit and fell to Earth or whatever it did, burn up the atmosphere. And so to me, that, again, put the physics aside, the unknownness of a detonation. Let me, here, I'm going to put on my Vladimir Putin hat. So I'm going to take and put a nuclear weapon in space. And what's it going to do? I'm not sure, but it's going to be really bad. And that is probably the more concerning aspect of this than anything else.
So it seems it would be, it's really bad for everyone who has assets in space.
Yeah.
So
exactly.
is the choice just, the Americans are more dependent upon space than we are, therefore it'll hurt them more than us. We'll be hurt, the Chinese will be hurt, everybody's hurt, but the Americans are hurt most because they're most dependent. Is that the best you can do in terms of sort of trying to ascertain the exact impact of such a detonation?
That truly is the issue. And in fact, for those that watch, I'm going to put a plug in for a movie. I don't know if I have to, I have to get royalties or whatever for the movie Gravity. But for those that watched the movie Gravity, it was about a Russia basically destroys one of its satellites in space, and the debris flies at around 20,000 miles an hour. It keeps flying around Earth, and it's that debris in space that you know what belt it's in from that location, but its original explosion pushes it in many directions, and a nuclear weapon has a lot of, I imagine it would use a lot of energy. Otherwise, they'd put a block of TNT up there. It'd be a whole lot easier. They wouldn't break any treaties. Everyone would be okay. Well, I wouldn't be okay with it. But you see what I'm saying? Putting a nuclear weapon there just changes the whole dynamic because of the radiation aspect and the ability to direct radiation, take out satellites quickly. So the answer is, I'm not sure what it gains aside from your argument, Adam, which is we're going to take it out for everyone, but they're going to be worse off with us. It's sort of like what we would do is we said, we're going to cut food production by 50%. Well, who's it going to hurt the worse? Well, America has lots of food. Okay. Now it doesn't mean that we want to cut our food production, but we have a lot of excess food. Countries that have very little food or most dependent on it, they would be hurt the worst. Now, I'm not saying that is a strategy for fighting. I'm trying to use it as an analogy. Does that make sense, Adam?
Sure. So thinking through this, maybe this is merely I sort of wonder, like, is it a weapon that you would put up that you could use for coercion, but because it would have such a negative effect on everybody, it becomes ineffective because we say, well, hey, listen, this hurts everyone so badly, you included, the Russians included, that we know you won't use it. So therefore your effort to use it as a coercive tool is ineffective. Is that, I'm trying to think through it.
I have, since I read this article, Adam, I have been trying to wrap my head around the strategic side of this because I'm not a strategist. I'm work the technical side. I can understand the technical aspects, and all of them are bad. Okay, prompt radiation, delayed radiation, its effect on much of our space operations. All of these things would occur, but even are worse with a nuclear weapon vice a conventional or chemical-based weapon. So the only aspect I see is it seems to be self-deterring. So then the question is, why even present it? So let's say, again, we don't know the background intelligence here, and I'm not claiming to be an intelligence expert in this area, but why would Russia even put out such an argument unless they are trying to gain some marketable corner, and they're going to play this out from a strategy standpoint? What advantage is there to Putin to put this out? And I think you're onto something that I hadn't thought about.
Yeah. So I wonder though, thinking back to Iraq, where the insurgents would have directional blasts purposefully, to take out our vehicles and stuff. Could you put something in space? Could the Russians put something in space that they could essentially direct the effects, control the effects, or do it in such a way that they could, make it bad for the Americans, but not bad for everybody? Is that, a possibility? Is there a way to do that?
Aside from EMP, which would be, more localized, you can't really see that in space. And again, compare a block of TNT, a ton of TNT in space versus a ton of a 1-ton nuclear weapon. The only difference between the two are the prompt, as I said, the prompt radiation effects, which are those direct effects to take out satellites. But it's that debris, long-term debris aspect and is really a concerning part of that. I will agree that anything that you imagine could survive the impact of the X-rays, the thermal energy, the direct radiation from the protons, etc., that would be localized but short term. It's that long term piece that really bothers me, that I can't think through why you'd want to put a nuclear weapon up there for any other reason than to just take out space, take it off the map.
Well, so how, I was, thinking about it. So if, let's say, Starlink satellites are, I think they're at a couple hundred miles up, something like that.
Yep.
So we go from a couple hundred miles up to, GPS is at, 22,500 miles up, something like that. And then we've got some, satellites in highly elliptical orbits and that go out much further on the ellipses. And I wonder if you put that, that weapon at, let's say, 400 miles or 500 miles up, how far would that reach? Would it, would GPS be safe? And if you put a weapon out at, let's say 22,000 miles, would everything, down at, in low Earth orbit, would the LEO satellites, would they be okay? How would that? Because space is pretty big. I mean, it's not exactly small. It's quite big.
Yeah, but our GPS satellites are not like on the other side of Jupiter either. So, I mean, you have to co-locate with the Earth in order to interact well with the Earth. I mean, the power requirements change as you get further away. So that's the reason our satellites are, drawn close to the Earth in the first place. But you are onto something there. Again, it's an unknown piece, and now you got to think it's this through. But the lower in the atmosphere you get, the more that radiation gets absorbed into the atmosphere. The debris, of course, burns up in the atmosphere. And I mean, that's the whole reason why we're all so fortunate to be born on Earth, because had we been born on a planet that doesn't have an atmosphere, that radiation would have killed us long before we ran out of air. Well, I don't know. I have not done the calculation. But anyway, the point is, if we had no atmosphere, the radiation would come to, would be killing us all the time, because the atmosphere helps us survive and our magnetic field helps us survive. So, so in the end, the atmosphere does provide some protection. So the answer to your question, probably the bigger answer, and maybe again, I'm a scientist, so I want to think about this and do the calculations in my head. I haven't done it, but I would say the closer to the Earth you are, the less of a chance that debris, first of all, is going to be, orbiting the Earth. It's going to interact with the atmosphere and probably reflect out to the exterior or come to rest because there's a force of drag from the atmosphere on it. So it would slow it down. So as you get closer in, you become more survivable. In fact, that's the other way to do this, is to have communication networks that are very close to Earth, like airplanes, like balloons, like antennas outside your house. They're close, but unfortunately they don't have the global reach like a satellite does. They don't have the persistence. They don't have the weather. It's all a trade-off. It's all an engineering trade-off. And so again, our satellite constellations are where they are, and they are subject to this radiation that you're talking about.
Okay. So speaking of radiation, so just sort of thinking about it, thinking about nuclear weapon detonations, at 600 feet above ground zero or 1,000 feet, when we do those calculations and, we can see what that propagation distance looks like for, prompt ionizing radiation. We know what that looks like. But when you get up into space and, space being essentially a vacuum, how does that radiation, how does being in a vacuum change how radiation propagates? Because, I mean, we clearly know atmospherics influence it, but how does it change? Because I just wonder, like, if something's if that detonation goes off at 500 miles, above the Earth, how does that, because, Starfish Prime was at 250 miles, I think.
Yep.
And we sort of understood what it did, but back then there was, essentially there was no satellites. So
it took out two satellites, right? Track 2, and I can't remember the other one, but it took out the satellites fairly quickly, like 6 days, 8 days.
Yeah, I mean, that early days where we just had, and we only had a few, but we didn't have these layers of orbits. And so I guess my question is, how would that radiation affect those satellites? How does that radiation propagate from, say, 500 miles up to 22,500? So
first of all, when you're essentially out of the, you're in a rarefied atmosphere and above. So, it's hard. Maybe if Chris was here, he'd tell me a specific number, but it's hard to corner the market on what do you call space and what do you call outer space and inner space or whatever you want to, atmosphere. So we'll say we're in a rarefied atmosphere and above, where the density of the atmosphere is very low. Then electromagnetic radiation basically flies in straight lines. So when the detonation occurs, your X-rays are basically starting at a point and flying in all directions. Okay, and they're going to fly in that direction. I just use the word fly, they propagate. So the electromagnetic X-rays are traveling out in all directions from the detonation. The ones going toward the Earth will interact with the atmosphere as they get closer to Earth and eventually get absorbed into the atmosphere, resulting in heat. That's why we have a thermosphere. It basically, X-rays are doing that constantly from our solar system, and they're basically interacting with the upper atmosphere. So you have the heat in that, it results in, X-rays result in heat there. The ones going, say, toward the moon, they're going to keep flying until they get to the moon. There's nothing in the way. So that's the true direct result. When I say line of sight, that's what I'm talking about. And that radiation flies off. It's instantaneous, and it's done after the detonation. It's the debris which has charge on it. So you have protons, which are positively charged, and electrons, which are negatively charged. They're going to follow the magnetic field lines, and they're going to follow the magnetic field lines, and they're going to feel a Stokes force. For those of you physicists in the audience here, basically you're going to spin around those magnetic field lines, and they're going to start following those field lines, and they're going to, depending on their initial kinetic energy, they're going to go to different altitudes before they end up getting drawn into a magnetic field line and follow that around the Earth. So that charged particles get moved by that.
Is this like when we're talking about the Van Allen belt and
very similar? Yeah.
Yeah. Mm-hmm. And the impact of pulling debris into it and.
Right. But remember, the debris is doing two things as it's traveling. One is it's being pulled around by the magnetic field. But the other thing is it's decaying over time. So it's very highly radioactive. Again, listen to my podcast from the NIDS view on fallout, but it's highly radioactive initially, and it decays over time. But as it's decaying, it's emitting radiation. So if it's emitting electromagnetic radiation, then it's impacting, as did in the Van Allen belts, as did following the Starfish Prime event. It's impacting those satellites and continually damaging them to the point where the exposed systems, especially the power systems that are taking power from the solar system, those solar panels are exposed. I mean, they have to be. You can't put a cover on a solar panel and then have it collect solar energy. So it's terribly badly exposed. And in fact, that's what killed the satellites following Starfish, was that the power systems died. They lost power because the solar systems were damaged and they would ineffectively collect solar energy.
Okay. Well, so, as we wrap up the show, let me ask the final question. So for our listeners who are sort of trying to work through this as you and I are, what's your takeaway for what we know and what we should be thinking right now?
Well, I would, when I look at this again, from a scientific standpoint, I can't wrap my head around why you would want to put a nuclear weapon in space, aside from maybe distributed EMP and EMP on the ground. And we didn't get the distributed EMP, and I'm not going to have time to talk about that. It's a little difficult to worry about. But we talked about the radiation aspects and then the EMP. Aside from the fact that you could take out a lot of space with a nuclear weapon in space, there are no technical reasons why a nuclear bomb can't go off in space. It doesn't need air, so it would just need the same requirements to detonate on the ground. So most of what happens in space, it's not a technical challenge to put it there. All the advantages of a nuclear weapon in space: small size, high power output, and the advantages of the radiation and the dispersion and the delayed radiation aspects. Those are all advantages from a military characteristic standpoint, except that, as you said, or you can think of it as I was an Army officer, so we looked at survivability of following nuclear weapons use. If you use a nuclear weapon in an area, or if you use chem or bio in an area and you want to occupy it, you can't until the levels of chemical, bio, or radiation are low enough to occupy it. The same is going to happen in space, but that's going to be a long time. And I just don't see, my view, and again, someone can come back on this podcast and I'd be happy to listen to them. I don't see a grand advantage aside from your comment, which is we'll take it out for everybody and we will negotiate from there. And it does become a negotiation point. I'll give you that.
Yeah. Yeah. Well, we're about out of time. It's one of those topics where you're just like, what's the play here? It's a question of where you want to say, well, how well do we understand Vladimir Putin and what he values? And that's really what it comes down to, because the science is bad for everybody. So I guess we'll end our conversation here. But Jim, thanks for joining me on this episode of the NIDS View, and we'll keep following this, and if we get more, we'll bring it back up. So
I hope we can get some feedback at nids@thinkdeterrence.com, or ask NIDS, one word, at thinkdeterrence.com. Send us your comments, and we'd like to respond to those things or ideas. So, but I agree with you, Adam. I think this is an interesting topic, and it's just starting to heat up, I believe.
Yeah. All right. Well, Jim, thanks for joining me, and thanks to you, the listeners, for joining us on this episode of the NIDS View. And as always, we want to encourage you to think deterrence.
Thank you for listening to the NIDS View. This show is produced under the NIDS Podcasting Network, a division of the National Institute for Deterrence Studies. NIDS is a 501c3 organization dependent upon donations to provide this podcast and bring about awareness of the peacekeeping value of U.S. strength and our national deterrence. You can catch all of our podcasts or provide feedback at thinkdeterrence.com. I would like to thank our producer, Kimberly Charrington, our sponsors, and all the fantastic members of the National Institute for Deterrence Studies for making this podcast possible. Stay tuned next week for another exciting and informative The NIDS View.